Hello, guys. I hope everyone can see my screen and am I audible to everyone?
Yes, Madhav.
Yes.
Yeah, thank you, Prashant. We'll start here. So, yesterday we completed our transportation topic. Please make sure you practice well because whenever just completion of the subject, your memory will be on the fresh page. If you start at that point of time, you may remember or understand easily without any confusions or any further questions. Even if you have some questions arise in your mind while preparing, or how so and so values are taken, this type of questions, you may reach out to me on a earlier time so that we can discuss on that questions or problems which you have. So I encourage everyone, whoever attended the session or whoever listened to the recorded sessions, please go through the transportation which we completed on uh, yesterday, because transportation and surveying is more or like very much related topics. Somewhat there are connections between like elevations and grade percentages and the lengths of the roads, which how we indicated those, what is how why we need to use in that way. These are all the concepts here and there they juggle. So please make sure you read that on a first instance without any delay. And coming to today's topic, surveying, there are, in your handbook it says surveying carries 6 to 9 marks, but most of the times it was like 6 most of the times, or else 7. So I'm going to be more genuine in this case, because because I'm teaching this subject. I am not gonna say you can expect anywhere between 8 or 9. This is no. You will not get this much of marks. Even if you get 8 marks, somewhat it is related to transportation. Okay, so I could say it is more or like 6 to 7 marks. But even if you get 6 or 7, also this subject is very easy compared to other subjects which you have the lot of background understanding should be background knowledge should be needed for answering some questions. But for surveying, it's just like few topics is just simple math. You should use just simple math. And for few topics it's just uh, formulas, which in those formulas also one or two formulas need to be dealt very logically. Other than that, not logically, you need to remember some thumb rules. Other than that, it is a easy peasy subject. But one tricky part in surveying that we are going to discuss in our next slide. So it's just 6 to 7 marks, but don't ignore, because it is a easy subject. When you read along transportation, it makes more sense and you will understand in far better way. Okay. And if you see, this is the syllabus of surveying topic. So first one is angles, distances, and trigonometry. Second one is area computation. Third one earthwork and volume computations. Fourth one coordinate system. Fifth one is leveling. So here the tricky part. If you dealing with any kind of subject, be it transportation, be it statics, be it geotech, any kind of subject, you have certain pages. It says from this page to this page, you'll see the you'll see the formulas of transportation subject. Maybe you may in the last class we discussed about queuing analysis, that 4 or 5 formulas in some other place. If you see statics, there is prescribed pages. That pages alone you can, if you read the if you go through that area, you will answer all static questions. For geotech, it has specific fixed numbers, number of pages. But coming to surveying, that is not like that. You will find angle distances and trigonometry in math area, for formulas in math area, and area computations and earthwork computation just below the transportation, which technically is the only one page which dealing with the surveying topic. This is the only page dealing with surveying topic. And coordinate system you'll again see in math topic. And unfortunately, you may find one formula for percentage grades maybe in math, but I don't encourage to see that one. Just use your fundamentals. Leveling, you don't have any formula in handbooks. And in this 6 to 7 marks, I'm breaking it down. You'll get 2 to 3 marks from area computations and earthwork volume computations, 2 to 3 marks from leveling itself, and remaining to coordinate system and angles and distances and trigonometry, you'll just get 1 mark or sometimes two. If you get 1 mark from 2 marks from 1 mark from here, maybe you may get area computations 2 marks and leveling 3 marks, or leveling 2 marks and area computations 3 marks. So like that, these marks are like divided. So make sure you go through each and every topic. In all the topics, it's just like basics. You don't need to remember all the, like you don't need to recall all the topics which you dealt in your BTech, bachelor's or master's. And coming to this surveying, unknowingly, we civil engineers most like most attracted or have most love towards surveying subject. Why? Because when we are joined in our bachelor's or in like bachelor's, this is the first civil engineering topic we'll deal in our first years of or first semesters of our college or university. So, in this condition, we are eager and excited to learn something. And for surveying, it is more or like even if you don't understand something at the in the class, you may end up understanding it in the field. You have field laboratory in your curriculum. So like that, you'll understand what's the concept, how is it, how we are using that in real world applications. You'll know everything, and you end up remembering what is work from whole to part, what is basics of chain surveying, what is the error lens in chain surveying, and what is compass, what are the errors you may get in compass, what is theodolite, what is auto level, what is dumpy level, what is total station, what is Bowditch rule, what is what we call traverse, open traverse, these all things. But remember, we are not learning or discussing the fact or matter in our bachelor's or master's. We are dealing the surveying in point of view with fundamentals of engineering. So you need the other set of syllabus, specific set of formulas and knowledge to get full marks out of it. And I I appreciate if you have the background knowledge which I talked about. For what are the rules of trigonometry? What is Bowditch rule? How we gonna calculate errors? What is latitudes, departures? If you know everything, if you remember each and everything, it's fine, superb. Okay, you need to have that background knowledge, mainly if you are in a construction field or working as a inspector or in surveying field itself. You need to have that background idea. But coming to the FE, unfortunately we just need few of them to get full marks out of it. It's mostly a good news for us, but most of the students felt we are teaching less, like why we are teaching only this much, we are not touching any background. So there is no such thing. You need to remember all those things. It's just enough what we are teaching. And I encourage you to practice more problems so that you'll understand what is required and what is not required. Okay. And if you see in handbook 10.4, 309 is your one page number that only deals with this whole topic. Okay. And one thing, this is the order of syllabus which is mentioned in your handbook, but we are not gonna see in the same order. So why? Because the coordinate systems is the fundamentals or the basics of surveying, and then we see first that, after that we jump into the angles, distance, and trigonometry. Then we come in then we discuss on area computations. Then we jump into volume computations. After that we deal with leveling. Okay, so this is the order we're going to discuss our syllabus. Coming to definition of survey. Okay, I pick someone to read this one. Vishal,
Yes, Madhav.
yeah, can you please read? Are you able to see my screen?
Yes, I can see your screen.
Yeah, can you please read the definition of surveying?
Surveying is a technique of determining the relative positions of different features on above or beneath the surface of the earth by means of direct or indirect measurements, and finally representing them on a sheet of paper known as plan or map.
Thank you. And Chiranjeevi, could you please read the second or second definition?
Surveying is the science and art of making all essential measurements to determine the position or what
Position, sorry. Yeah,
relative
position.
position of points or physical and cultural details above, on or beneath the surface of earth, and to depict them in usable form to establish the position of points or details by American Congress on Surveying and Mapping, ACSM.
Okay, so I took these two definitions. One is from textbook and one is given by American Congress of Surveying. Um, uh, um, so this is the definition of surveying. Surveying definition itself saying it is art of making or technique of determining relative position of different features on or above or beneath the surface of earth by means of direct or indirect measurements, finally representing on the sheet of paper knowing as plan or map. So what we'll do, I assume this is a ground level. On this ground level we found the, okay, we have some points. That points are our interest to find the maybe lengths, angles, elevations, anything. Okay, so how we find those points or whatever we have? We need to have one position that already we knew whatever the requirement we want. So this point is known as benchmark. Benchmark. It mostly comes from mean sea level. In elevation topic, we deep dive into what is mean sea level, how many means, what is the mean sea level taken by US and everything, just for the background knowledge. Okay, so we know one point. Based on this point, from this point to this point, we find lengths, we find elevation difference, elevation differences, elevation differences, and angle between these 2 points, angles or whatsoever, by means of maybe direct or indirect. Okay, so first we need a point we need to have that point in as a benchmark. Based on that point, we relatively uh, like measure the lengths or measure the angles or position the point on the earth, not only on the earth, beneath the earth, beneath the earth surface, or above the earth surface, or on the earth surface. We place we with using direct or indirect measurements, we place or find or determine those points, and we finally represent all of those points in a paper. That is called map. So this whole process is called surveying. Why I am trying to say this one is, you may I see few questions in some of workbooks. They directly asking some what is the definition of survey kind of thing, but these days not they are asking, but I think it's makes sense to give you the definition of surveying as we are discussing the surveying concept. Okay, so this is the definition of surveying. And coming to, as we discussed, we directly jump into coordinate system. Okay, basically we just if you if this is your house site, maybe a 90 feet by 60 feet square block you have. How you find the areas of lengths of this one? You use just tapes, maybe chains, maybe total station or some kind of things, and measure the distances, and using the simple formulae of rectangle b into h, you found out the, sorry, b into l, you found out the breadth into length, you found out the area of that one. There is no problem with that. Why? Because even we considering we all know earth is a spherical like surface. We are intended to calculate or find out the area on that surface. Even earth is spherical, it has some curvature, we are not taking it into account. Why? Because at that least, like that much smaller area, you don't need to consider that uh, curvature of earth. Okay, it is very much neglected. If I say 9654, so it may be 54,000 feet square. Even if you consider the earth curvature, it may be 540, 0.5 or 0.5 feet square, something kind of thing. It is very minimal. So that's why we omit those curvature in, we don't take the curvature into account. As we understood that for small areas we have one, we are not taking the what we call earth curvature into account. But for the large areas, if I want to measure the state boundaries, in that condition, we will take earth curvature into account. Okay. So I know we need to consider uh, for some minimum or small lengths or areas, we don't need to take earth curvature into account. That surveying is called plane surveying. Okay, but for larger areas, we need to consider earth curvature into account. So that surveying is called geodetic surveying. So earth curvature taken into account, that is geodetic surveying. If at all we are not taking that into account, it is plane surveying. Okay, so we are engineers, we are not allowed to say some much, this much, minimum, maximum kind of words. We need to quantify everything. We need to quantify everything. So for that condition, if you are in, if you are here, if you are here in any direction, if you go 12 miles, if your interest of surveying is in 12 miles, or I can say this 12 miles, 12 miles, 12 miles, 12 miles, in this region, if you are finding out any kind of area, then you don't need to consider earth curvature into account. If it is greater than 12 miles in any direction, you need to consider that you need to go for geodetic surveying. So break this ambiguity. To break this ambiguity, state plane coordinate system and universal traverse vector system will enable to made as it on flat plane while still accommodating larger areas. So state plane coordinate system, like what we call US Coast and Geodetic Surveying of 1930s, they come up with 124 geodetic zones or coordinate systems they developed. And if you are in one zone, you don't need to be considered, you don't need to take what we call earth curvature into account. If you are dealing with two zones, then you need to consider you need to go for geodetic surveying. Okay. And geodetic surveying is more costly than plane coordinate system survey. Okay. So, and in this straight plane coordinate system enables to find out convert latitudes and longitude into two-dimensional Cartesian coordinate system. Okay, we know this is Earth and we have longitudes and latitudes. So for even for what we call state boundaries and all, even we surveyed on the we considering the earth curvature into account, we surveyed the US boundaries, but we cannot we are unable to map that on a spherical surface. We need to map that on a piece of paper. As we discussed on the definition of surveying, we need to map that on a piece of paper. So paper is two-dimensional. So this SPCS, which is known as the State Plane Coordinate System, enables this curvilinear coordinates, which are known as latitudes and longitudes, conversion into two-dimensional Cartesian coordinate system to make the maps more accurate. Okay. This plane coordinate system offers key advantages. One, we will specify the northings and eastings, which is nothing but x and y's of a point. If you have 2 points of length, we can find x comma y coordinates, x comma y, which is nothing but northing and easting. Y is nothing but north side, x is nothing but east side. We'll find out on x comma y is nothing but y is northing, x is easting. So like that, even if they call northing and easting, it means x and y points or the coordinates. Okay. So after transferring or converting those latitudes and longitudes into two-dimensional Cartesian coordinate points, we'll easily using right angles or the triangular formulas, or trigonometric formulas, we'll definitely cut down the complex calculations into very minimal calculations. That's why we use this state plane Cartesian coordinate system, state plane coordinate system. And because of this 124 zones, this survey has, whatever the survey we are doing, it gives very much accurate results, and the errors is less than 1:10,000. So that's why we use this state plane coordinate system for our any kind of cities in US. So this allows us to plan safely in urban areas and meet the all surveying recruitments. If even if you open the Google Earth or Google Maps, you will find out the property lines. That much accurately we can plot our maps in which are in paper or in sites also. So that's why we use this one. this is how we convert the rectangular coordinates into polar coordinates. Polar coordinates is nothing but latitudes and longitudes kind of thing, and converting from polar coordinates to rectangular coordinates. That means we are converting the latitudes and longitudes to general lines. Okay, so if you see, this is just we have x and y coordinates. It's just simple, sorry, simple math. um, I believe you covered the static subject. In static subject also you have one force. We resolve the forces into x coordinate and sorry, x coordinate and y coordinate. For x is equal to r cos theta, y is equal to r sin theta. So like that we calculated that one. Same thing here also. So that's why you will find out these equations in math page number 36 in math section. Okay, so this is the whole concept of coordinate system. In coordinate system, mostly you may get, if at all in theoretical question, you may get plane survey ignored the earth curvature until if it is under 12 miles in any direction, you may expect that one question. And how many geographical zones we have in our US, that is 124. And not what is northing, what is easting, that is x and y points, maybe, I'm not sure. But you may expect this question. Surveying errors is lesser than 1 in 10,000. But questions from these are like in theoretical, most likely not gonna come, like maybe have lesser probability. You may get one you may expect one question, problem like problem solving question from this rectangular coordinates to polar coordinates, or polar coordinate to rectangular coordinates. Or it may be a integral part of that angles trigonometry chapter also. So that's why make sure you learn, you understood this concept very well. It it not only useful for surveying, it used for statics, mechanics of materials, everything. So this is the basic concept. Just we are resolving the force, resolving a line into x coordinates and y coordinates. That's it. If you have some x and y, we are finding the resultant. That itself resolved forces. Again, we are coming in reverse direction, and we find out in the x and y coordinates. So that's the whole thing about a fourth chapter. And coming to the first chapter, latitude and departure, we have these words, latitude and departure, which is um, very much similar, common, that what we dealt here in this rectangular to polar coordinate system. You can see x is equal to r cos theta, y is equal to y sin theta. Here I can say my x is um, my x is departure and my y is latitude. Same formula. The definition, like the nomenclature was different. Okay. So uh, definitions. So if you see the definitions, latitude. Latitude is nothing but north-south component of a line. So north-south coordinates components of a line. Positive, if this line is like this, running like this, if it is in positive, then it is a north. If it is run towards south, it is negative. Same like departure, the east west component of a line, east and west component of a line. If line runs towards east, then it is positive. If a line runs towards west, it is negative. So this is the whole concept. We are just resolving the forces as we did earlier. Latitude, not force, this time line. Y is equal to L cos theta, x is equal to L sin theta. As simple as that. And I think most of you remembered this one. We solved number of problems in bachelor's. So these are bearings and azimuths. Simply we can say whole circle bearing and quadrantal bearing. if you remember these things. So that the whole concept we called as bearing and azimuth. Bearing is nothing but quadrantal bearing system. Azimuth is nothing but whole circle bearing. So, but for the FE nomenclature, we called it as bearing and azimuth. Okay. So, what is bearing? The direction of line relative to north or south. A direction of line will be told as like so written in such a form with relative to north and south line. Maybe they can calculate or measure this angle in clockwise or anti-clockwise. So that is bearing. Okay, from north or south line. Coming to azimuth, the direction of line relative to the only north, and only calculated from clockwise, measured in clockwise direction from the north. So conversion between these two bearings azimuths are necessary for calculations. Okay. So, okay. So if I say my angle is 45, then how can I represent in quadrantal system and whole circle bearing system? Can anyone say this to me? How can I represent what is my theta 45? I have a line which making 45 degrees, How can I write
North,
this in whole circle bearing and quadrantal bearing?
north 45 east
North
in
45
quad
is perfect. And
and
in whole circle bearing, it is 45 degrees.
45 degrees.
Perfect. And if you see, each quadrant have 90 degrees irrespective of any system. Okay. If you are in between 0 to 90 degrees, it is in first quadrant, then you can write it as north theta 1 east. Okay. Or north theta east. If you are in between 90 to 180 degrees, then you are in second quadrant, first quadrant, second quadrant, third quadrant, and fourth quadrant. Okay. I'm sorry, fourth quadrant. So same for this. So if you are in second quadrant, you can represent it as south theta E. If you are in third quadrant, which is like 180 to 270, you will write it as south theta into W, that is west. And if you are in fourth quadrant, 270 to 360, then you can represent it as north theta west. So if you see, first we write it as north south, always it coming north or south. So it's saying that from north, this much amount of angle we are deflecting towards west. It is saying like that. It's saying from south, we are deflecting some theta angle towards east. Okay. From south, we are deflecting some theta angle towards west. From north, we are deflecting some theta angle towards west. That's what it's saying. So if I want to find this angle, I can write it as 180 minus theta. For this 180 minus theta. Okay. If I want to find this angle in third quadrant, I can write in my third quadrant, it is 180
Sir?
plus theta. If I want to find in fourth quadrant, I can say 360 minus theta. I made one mistake. It is 90 plus theta. I'm sorry. Someone is about to say that, right?
Yeah, sir, can you
Yeah.
please switch the color of the pen, because sometimes it's
Okay.
hard to understand. You're saying
Okay.
this, it's hard to point out
Okay.
where you're
Okay.
writing.
Okay. So 0 to 90 degrees is my first quadrant. 90 to 180 is my second quadrant. 180 to 270 is my third quadrant. 270 to 360 is my fourth quadrant. If you see in quadrantal bearing system, for first quadrant, I am depicting that north theta 1 east, south theta 2 east in second, south theta 3 to west, north theta 4 to west. That means north theta 1 east, no, sorry, south theta 2 towards east, south theta 3 to west, south theta 4 to, sorry, north theta 4 to west. So it's saying from north we are deflecting some theta angle towards west. From south we are deflecting some theta angle to east. From south we are deflecting some theta angle to west. From north we are deflecting some theta angle to west. So next I can say how I can write this one. If I have some theta, you have 0, 90, 270 and 360. Okay. So if I want to find my theta 1, if I want to find out my theta 1, if my theta is, so if it is represented as north 45 east, let make in this way. We'll come like first convert quadrantal to this one. So how can I represent this one? So that means from north, I am deflecting 45 degrees north, 45 degrees east. So I am deflecting from north to east 45 degrees. Then in my case, it is in first quadrant. So what is my angle? 45 degrees. So whatever in between these here, you can directly write it as whole circle bearing, or whatever the angle you have in first quadrant, if it is less than 90, you can write directly as north some that angle into east. Why? Because we are calculating in clockwise. If you see, we are calculated in clockwise. Here also we are coming from north to east in clockwise direction. So that's why the exact same thing. But coming to the second quadrant, first, second, third, okay. Let me, first quadrant, second quadrant, third quadrant and fourth quadrant. Okay. So if I am coming for second one, I am saying south some theta 2 to east. If I say it is 30 degrees, south 30 degrees east, that means I am measuring this angle. I am measuring this angle. But in a whole circle bearing, I want to find from this to this. So how can I write this one? What's the easiest way to write this one? South 30 degrees east, I can have 180 minus 30 degrees. So it is 150 degrees. Okay. So like that we can write this formula. And coming to third one, we are measuring the angle from this point to this point. We are measuring this angle. Let's say south 40 degrees west. That means from south we are traveling 40 degrees. At that 40 degrees we have the line. So that's the whole thing. We know this is 180 degrees. So if you want to find this angle, just add this 40 degrees to 180. So I can write, if south 40 degrees west, then it is equal to 180 plus theta, that is equal to 40 degrees. That means 220 degrees. Okay. Coming to fourth, we are calculating it in negative. That means anti-clockwise. That means negative. But we want to find this angle in whole circle bearing. We have this one. So what can I do? North, let's say 30 degrees west. What can I do? 360 minus, because it is anti-clockwise. So 360 minus 30 degrees gives us 330 degrees is the whole circle bearing. Okay. So I believe everyone understood this one, or do I need to say how we manage this, calculated this one? Everyone good, right?
Yes, sir.
Okay. So coming to next part, I believe this is the last one. Yeah, perfect. So coming to the latitudes and departures. So we already knew that latitudes or departures are the south, north, south, and east-west projections respect to a line segment. So we can write in this way as northings and eastings of a coordinate points in the traverse. So therefore, the line segment, if you have a line segment AB, let's say, if you have a line segment AB, you have northings and eastings, x1, y1, x2, y2, let's say in this way. So if you find the latitude differences between northing points AB and the length of the line, this length of the line is nothing but difference between latitudes, like northings and departures, or sorry, latitudes and departures, or northings and eastings of that point. Let's say uh, my x2 is 1, x2 is 1, y2 is 1 comma 2, 1 comma 2. My x1 y1 is 6 comma 7. So can I find my length or not in this situation? Yes, I can. So in x direction, what is my length here? It is 5. That means we are traveling 5 feet, and in y direction we are traveling again 5 feet. So we are traveling like this. Okay. How? I just neglected my x1 minus x2, y1 minus y2. So my x1 is 6 minus x2 is 1, that is equal to 5 units. Okay, my y1 is 7 and my y2 is 2, that is 5 units. So in x direction I am traveling 5 feet, and in y direction I am traveling in another 5 feet. So I want to find this length, this hypotenuse length. We need to find this length. So I know my based on this I can find my thetas, and based on that I'll end up doing like tan theta is equal to or something. You can simply use this one, right? Right angle principle.
Pythagoras.
Yeah, Pythagoras principle. Thank you very much. So you can find the hypotenuse length L is equal to root of 5 square plus 5 square. This is simple. So even if you have some theta angles, if you don't know your eastings or northings also, using this theta, you can resolve this into forces. That is nothing but latitude and departure, L cos theta and L cos theta and L sin theta. So using this also, you can find the lengths if you know the thetas. So this is the case, guys. And we have two traverses. One is open traverse, one is closed traverse. Okay. So in open traverse, what is the difference between open and closed traverse is, in open traverse, you have a starting point, you have another different point, different ending point. The starting and ending points are not joined. For closed traverse, the opening point and closing points will join at same point. So that's the main difference between open and closed traverse. Open traverse we generally use to find the areas or thicknesses or some different types for road surveying. We use this kind of roads, channels, rivers, or something which is definite path. We'll use this open traverse to survey these things. For closed traverse we use mostly for fields, to find out the areas or the earthwork volume. So like that, we use this closed traverse. So we don't have any issue with open traverse, but we have an issue with closed traverse. So closed traverse is a geometric figure. So in this, the total sum of deflection angle is 360 degrees. So this is interior angle and this is exterior angle. If you combine interior and exterior angle at a point, then you will get 360 degrees. Okay. And sum of interior angles. Sum of interior angles. Here, if you have interior angles, if this sum of interior angles is how many sides you have? 1, 2, 3, 4, 5. 5 minus 2 into 180. Okay. So I'm not saying 5 minus 2, literally. I got this polygon, so I'm telling my n is equal to 5. Okay. So any polygon, if you have n is equal to n number of sides, n minus 2 into 180 is your interior angles. So for exterior angles, we have exterior angles too. These are the exterior angles. These are the exterior angles. To find the sum of exterior angles for a polygon, 180 into n plus 2. So n is number of sides. So like that, we'll find out the traverse, interior angle and exterior angles. Okay. So these are the trigonometric functions. To find out any angles, we use law of sines or law of cosines also. These two formulas we can use without any problem. And if you get any problems which is very similar to this one, you can feel you are allowed to use these formulas. Okay, but it doesn't specify these are the formulas for surveying, but you will find these formulas in page number 37 and 38 in trigonometry in your mathematics section. So that's why we need to use different sections while we are dealing with surveying. So, do you really need any kind of formulas to deal all these questions? It's just simple math, right? So, whatever the latitudes and Cartesian converting polar coordinates to Cartesian, like general coordinates or latitudes or departures, we generally use these formulas, and converting these azimuths and bearings, we just need to use the graphical representation. And yeah, these are all the basic 10th level math, 10th math. And trigonometry is also our 10th math. It like not 10th grade, but fortunately we have formulas too in handbook. So that's why they don't generally specify some pages given repeating the formulas again over there. Okay, I believe everyone understood this session, and we'll see few questions right now, like 3 to 4 questions today. So that will help you to understood what we discussed today. Okay. Yeah, Varshini.
Yeah.
Yeah, can you please read first question?
A surveyor placed the theodolite at a point A and measures a building top and bottom. The angles observed from the point A is 5 degrees and 3 degrees. Using the tape distance measures from point to a building is 150 feet. Calculate the vertical height of the building.
So he wants us to find the just give me a
Vertical.
second. Okay, appreciated whoever give the answer to me. So what we'll do, we'll just understand the concept first. There is a theodolite placed, and we have a building over here. Building over here. We placed one theodolite. This is our line of sight. Okay. He tilted. He based on using the readings. He first seen the top of the building and he calculated 5 degrees, and next he just checked the see the bottom of the building and calculated this is 3 degrees, and we want to find this h height of the building. So I can divide this part as h1 and h2, right? So based on this, I can get my equation as total height of the building is equal to h1 plus h2. So fortunately, I know my length between point A to the building, that is 150 feet. Perfect. So 150 feet. So can I able to find this height without using my handbook? Absolutely. I can divide A, I can write this as O, this as B, and this as C. So take the triangle AOB, which looks like 150 feet OB, A, 5 degrees, and I don't know my H1. So can anyone tell me what is the formula for this one? How can I find this one?
20.98. We use tan 5 times 150 and plus tan 3 times
Perfect.
150.
Tan theta is nothing but opposite side by adjacent side. So opposite side is H1, adjacent side is 150. To find H1, I just simply take this into this side. 150 tan, what is my angle here? 5 degrees. So what is the answer?
13.12.
13.1 feet. Perfect. So coming to next thing, I just take my triangle as A, O, and C, which looks like this one. This is 3 degrees. This is 150 feet. O, C, A. I want to find my H2. So did we need to change any formula here? No. Tan theta 2 is equal to H2 by 150. So 150 into tan 3 degrees is equal to your H2. What is my H2?
7.8.
7.3.
7
It should
point?
be around 7.3 because the total answer would be 20.98.
Okay, no problem. I don't require absolute answers. So if you combine these things, it is like 20.42 feet, which is very much related to 21 feet. Do we need any kind of handbook to solve this one? Absolutely no. And you may feel, did this much of silly questions you gonna ask us in FE exam? Yes, absolutely. We're gonna ask you this type of questions. Okay, so I'm not saying that this is a silly question. This is a good question to test your ability to understand the questions. Okay, so make sure this is this type of questions gonna ask you in your exam also, not the range you are thinking it's a big sophisticated questions or something. No. And can you match the following for this quadrantal bearing to horizontal bearing? So I can write this is my north, east, 45 degrees. Second one is north, west, north, south, east, west. So southwest 15 degrees. That means that is 15 degrees. And third line is south 4 degrees east. That means this is 4 degrees southeast. And next question, north 63 degrees west. So this is 63 degrees northwest. So how can what is my first value if I convert it into whole circle bearing? Come on fast. I need the
A is
answers for
4.
this really quick.
A
45.
is
Sorry?
4. A is 4.
No. I just need the angle.
Okay. A is
45.
45.
45, perfect. For next
And
question,
equation
195.
195.
180 and 15.
perfect. Third one,
Third one,
176.
176. Fourth one,
97.
297. So how we did? Theta is equal to theta, it's common. So whatever it is in 90 degrees, it's in first coordinate. So whatever the angle you have, you need to take that. It is greater than 180 degrees, and fortunately measuring from 180 degrees. So 180 plus, and it is in third coordinate. Let me change the color for you. 180 plus, so it is 180 plus 180 plus 15 degrees, that is equal to 195 degrees. So this is we are calculating from south, that is we are neglecting from 180 degrees, we are going away from 180 degrees. So 180 from minus 4 degrees, that is equal to 170 degrees, 176 degrees. And we are moving in an anti-clockwise direction from north to west, it is 63 degrees. So that's why 360, we have a whole circle bearing 360 minus 63, it is equal to 297 degrees. Perfect. Okay. So this is how we convert the angles from one system to another system, and the answer for this is A4, B3, C2, D1. You need to take that option. Okay, literally you have the options for these type of questions also. Pick the right answer. Okay, so coming to the third question, a survey line has CD is 80 meters long and has a bearing of north 30 degrees east. Calculate the latitude and departure. So we know that it is a 30 degrees north 30 degrees east line. We want to find the latitudes and departure, and fortunately we know the length of the line is 80 meters. So what is my latitude and departure? So let me clear. Departure is nothing but x coordinate. Latitude is nothing but y coordinate. So I can write this as L cos theta, L sin theta. Make sense? So L is 80 cos 30 degrees. Yeah. L cos 30 degrees. 80 sine 30 degrees. May I know what is the answer for these two?
69.28, 69.28 and 40. B1.
It is feet. Okay. Make sure you put the units. And yeah, B is the correct answer. Okay. If I am smart
can
enough
you-
to know what is the answer in this condition,
Excuse me.
what should I look after based on the
Can
options? Sorry.
can you solve this? Like I didn't get you how you got the 69.28.
Okay. So he's saying we have a line, slanted line. Okay. If this line is like I want to find out this length. I want to find out this length. I want to find out this length. Okay. This is what exactly he asked. If my line is like this, if I just draw a line, is it equal to this length? No, right? If I can build a triangle over here, right angle triangle, it makes sense. The hypotenuse is always greater than this length, right? Do you understand my point?
Yes.
So we need to calculate this length. He literally asking that, and we know the angle. Okay, this angle. So
30.
we know this angle, and we need this length. How can we calculate this one? Let's say what is I want to find this one. Okay, so what is my adjacent adjacent angle, like which angle gives you the relationship between adjacent side and hypotenuse? Cos, right? Cos theta is
Okay.
equal to adjacent by hypotenuse. Am I
Yes.
right?
Yes.
So
Yeah.
I'm just multiplying my L with cos theta. I know my L is 80 degrees and my theta is 30 degrees. So I just find out my X. In same way, he want me to find out the departure. So departure, that he wants to find this one. So I just find out my, here I can put my X. And how can I find my X? It is like adjacent side, see, opposite side by hypotenuse. So what is my opposite side here? Opposite side is sorry, sine theta gives you the opposite side to hypotenuse condition. So I just multiplied my L with sine theta. So like that we find out latitudes and departure. Okay,
Oh, okay. I got you. Thank you.
perfect. So yeah, coming to this, converting decimals into degrees, minutes, seconds. Um, Previously I told how to do, but I figured out something like it makes sense. You have calci in your hands. Even if your calci is not working, you have a virtual calculator to your attached to your exam portal. So if you find this anywhere, I'm using this calculator, you all know. So if I press this button, after, if I say 56.23 and I click this button, it's automatically give me the what is the angle value. So I don't think these questions make sense to discuss. um, but if we find any, I suggest everyone use this link. I just give this link to your WhatsApp group right now. Just see this video. Just see this video and know how to um, convert from decimals to angles to decimals, use without using calculator. Okay. So I just stop here. Please visit that video, and tomorrow we'll discuss. First, we discuss few questions, 3 or 4 questions, and later we jump into area competitions. Okay. So anyone have any questions right so far? We
Yeah,
are good to
Madhav,
go. Yeah.
I have one question. In starting of the class, you mentioned that y-axis represents sine theta, right?
Y-axis.
Yeah, in statics, we discussed y-axis represents
Yeah.
sine, yeah, and
Yeah.
x-axis represents cos.
Mm-hmm.
But in the question, you take it as y is sine theta. That has I
Mm-hmm.
have confusion over there.
Why I take y as sine theta? I am
Yeah,
finding out this one, right?
yeah.
So x departure is x. So x is sine theta, y is cos theta.
But in statistics class, we learn that x is cos, right?
Okay. So he does it says like it is your f and your x-axis is f cos theta.
Yeah, yeah.
No, I guess. Okay. Okay. Just give me a second.
Thank you, Naga. Thank you so much.
Thank you.
So basically, this subject is more like a scoring subject, surveying.
Yeah. Scoring subject. Yeah.
All right. How many questions can we expect from this? Like 3, 4,
Six.
6?
So
Okay.
sorry.
Weightage.
From this whole topic or just the chapters which we discussed today?
No. Whole topic, whole surveying. 6, 7.
Whole serving, yeah, 6 to 7 marks easily.
Okay. Thank you. Thank you.
Yeah, thank you.
Sir, can we get this document which you are teaching us from this?
Yeah, it will be uploaded in your app.
I did check, it's not there, but I don't know. It's gonna be tomorrow. We'll get that in 4 hours or.
Oh, okay. So here the thing, we generally upload the videos,
Yeah.
but we not upload the whole file like this PDF or whatever the PPT we have teaching in class until we
Yeah.
complete that whole subject.
Okay.
Because if you see some topics on transportation or surveying, there are some
Mm-hmm.
tips and tricks you need to be understand while going through the
While
class.
on video. Okay.
Yeah, on video.
But
So that's why we are not sharing this PPT or PDF. If you want, just text Venki. You just need those in prayer. He may give access to drive or something
okay.
like that.
Okay. Okay. Sounds good. Thank you. To whom? Sorry,
Thank
to
you.
whom?
Venki, that
Venki. Okay.
technical person which you um, like contacted for payment of fees or something like that.
Okay. Sounds good. Thank you.
Thank you.
Thank you. Yes. Thank you.
Thank you. Yeah. So
Thank you,
whom I'm
Madhav.
addressing? Thank you. So I believe someone asked me the question and I just lost the track. Who asked me the question?
Yeah, Lakshman. Yeah, I asked you the
Yeah,
question.
Lakshman. Okay. So if you see, for surveying, we are taking the angle here. Okay.
Mm.
We are taking the angle here, and this triangle is like this. I'm rotating this triangle in this way. So I'm taking the theta here. So what is my I need to find this one. I know this one. So that's why my L cos theta is this way. So for x coordinate, I'm taking L cos theta. Sorry, for my y coordinate, I'm taking adjacent opposite. Yeah. For my y coordinate, I'm taking L cos theta. For x coordinate, I'm taking, sorry, for my y coordinate, I'm taking L cos theta. For my x coordinate, I'm taking L sin theta. For coming to statics, your angle is like this. Okay. So you are finding resolving forces. For y, you are calculating it is in opposite. So like for y, it is opposite. So that's why for y, you are taking L sin theta. And for x, you are taking L cos theta. Make sense?
No, still I getting and confused it only.
Okay, just give me a second. So whoever have the no question or no questions or no doubts, you can feel free to go. Okay, just give me a second.
All right, sir.
All right, Sharif. See you tomorrow.
All right. Bye bye.
Bye.
Bye. Bye. Where is it? Why I'm doing like this? Perfect. So this is my length. Sorry, this is my line. Okay, Lakshman. For surveying, we are finding out the angle here. Okay.
From north
Coming to
to
yeah, north towards east. For statics, this is your force, and he measuring the angle here. This is theta. This is theta. So this is my theta. I'm just making this line.
imaginary.
Okay. For this condition, this is my theta. So this is my x coordinate. This is my y coordinate. Here, this is my y coordinate. This is my x coordinate.
Okay.
Make sense? Am I correct?
Yeah, good now.
Perfect. So if I want to find my x coordinate here, this is my theta. I know this is L. I know this is L. And if I want to find my x, how should I write my equation? It is opposite. So cos theta is equal to x by L. Okay. So
Okay.
x is equal to L cos theta. Okay. For this condition, my x coordinate is adjacent. Okay. So how can I write? Sorry. I am finding out my x coordinate, right? Yeah. So here I can. So here I want to find my x coordinate. So x coordinate is opposite. So I can write sine theta is equal to x by L. So L sine theta is equal to my x coordinate. Coming to here, my x coordinate is adjacent to my theta. So how can I write this one? Cos theta is equal to adjacent by hypotenuse. So I can write x is equal to L cos theta. This is the major difference between your force resolutions and line finding out latitudes and departure. This is statics and this is surveying. Okay?
Okay.
It makes sense, right?
Yeah. The main theme was adjacent by hypotenuse in both cases.
I'm not saying like if you want to find the y, if you want to find y, it is vice versa. It's basically where you placing the theta. It matters. And which way you are finding out. It's the matter. Okay. Yeah, Suresh, do you get my point?
Yeah, I got it.
Perfect. See you tomorrow. Good night, guys.